Hello, welcome to Chris's quick tips for Google Sheets.
Normal numbers that we all use on a day-to-day basis are decimal numbers, which are in a number base of 10. This has 10 numbers 0 through to 9. Other number bases in common use include binary. Binary is a number base of 2 and therefore only has 2 numbers, 0 or 1. Hex is also in common use, and that is a number base of 16, so that has the numbers 0 through to 9 and A through to F. Octal is also in fairly common use, and that is a number base of 8, which has the numbers 0 through to 7. Google Sheet has functions that allow you to convert between the different number bases. Whenever a number base other than 10 is shown, it is a string which represents the number rather than the number itself. So it's not possible to do arithmetic manipulation actually on a number other than a number in base 10. This rather complex diagram shows all the number base conversion functions in Google Sheet. The generic functions that will convert any number base from 2 to 36 are highlighted in gold. The base function converts from a decimal number to any number base from 2 to 36. The decimal function converts a number in any number base from 2 to 36 to a decimal number. Incidentally, the black highlights show where the conversion is to the same number base, i.e. there is no conversion. As mentioned earlier, the most common number bases are decimal, obviously, binary, hex, and octal. So Google Sheet has dedicated functions to convert from and to each of these number bases. The names of these functions use the first 3 characters of the name for the number base of the number to be converted, then the numerical digit 2, and finally the first 3 characters of the name of the number base that you want to convert to. This sounds complicated, but it's much simpler to read. So OCT2DEC function will convert decimal to binary. I think that most users will only use decimal, binary, and hex. So for most users, this table can be simplified to this table, which shows the functions that will convert between these 3 number bases. Let's have a look at these 3 functions in this table. The left-hand column shows numbers in decimal from 36 down to 0. The table has columns that convert the decimal numbers to binary, octal, and hex using the built-in functions OCT2BIN, OCT2OCT, and OCT2HEX. The second argument for these functions is optional and allows you to specify the number of characters in the string representing the number. If there are less characters in the string representing the number, leading zeros will be used to pad the string to the required length. It should be noted that the number of characters specified is the exact number of characters there will always be in the result. So if the number of characters to display the number is insufficient to allow the decimal number to be converted, an error will be reported. The error message will explain how many characters are required to display the number. It should be remembered that the numbers in number bases other than 10 are strings in Google Sheet and not numbers. This means that Google Sheet cannot add, subtract, multiply, etc. numbers in any number base other than 10. However, Google Sheet can sometimes be misleading and appear to give the correct result. However, this is accidental. In column E, I have added the hex number in the same row in column D to itself. You will note that in column F, I have indicated which results appear to be correct, but some results are wrong and others produce an error. So what's going on? Let's look at row 6, which produces the correct answer. The hex value 24 is being added to the hex value of 24 to give 48 in hex. Now this is 72 in decimal. In decimal, this is 36 plus 36, which is obviously 72. The same as the answer we got by adding the hex number 24 to itself. So for this row, the answer is correct. However, if you look at row 17, which is attempting to add the hex number 19 to the hex number 19, which Google Sheet says is 38 in hex. 38 in hex is 56 in decimal. So 19 in hex is 25 in decimal. So if you add 25 decimal to 25 decimal, you obviously get 50 in decimal. This shows that the answer that Google Sheet calculated of 56 in decimal, or 38 in hex, is wrong. So why is this happening? Google Sheet helps you by automatically converting strings to numbers when you try to do some sort of arithmetic manipulation, such as addition, subtraction, etc., to a string. However, Google Sheet makes the assumption that any string which is a number is a decimal number. Therefore, when you add the hex number 19 to the hex number 19, Google Sheet will make the incorrect assumption that the string is a decimal number. So it adds decimal 19 to decimal 19 to give decimal 38. So the result of 38 is correct, but it is 38 in decimal, not in hex. Row 11 demonstrates a different problem, where if you try and add two hex numbers together, which contain the hex characters A to F, then you will get an error message that the text string cannot be converted to a number. Since you are trying to add the string in D11 to the string in D11, Google Sheet will attempt to convert the string to a number, a decimal number, which only contains the characters 0 to 9. However, the string in D11 contains an F, which is not a valid character for a decimal number. Google Sheet cannot convert the string to a decimal number, so Google Sheet produces the hash value error and the more detailed error message if you hover over the cell. I've repeated the same calculation for decimal numbers down to 0. This shows that in other rows, for different numbers, adding the two hex numbers together produces either an error message or the completely wrong result. So the bottom line is, do not be deceived by a few results that seem to work. Google Sheet cannot perform arithmetic in any number base other than decimal. If you want to add, subtract, multiply, or do any other sort of numerical manipulation on a number in a number base other than decimal, you must first convert the non-decimal numbers to decimal, then do the arithmetic manipulation of that number, and then convert the result in decimal to the required number base. Google Sheet provides more functions that allow you to convert other common number bases to decimal. These functions use the same naming convention, so to convert binary to decimal, use the function BIN2DEC, BIN2DEC. Columns G to I simply convert the string in columns B to D back to decimal. So the decimal number should be the same as the decimal number in column A, which was converted to a different number base in column B to D. Note that when you convert decimal numbers to another number base, the result is a string, but when you convert back to decimal, the result is a Google Sheet number. These conversion functions can also handle negative numbers using 2's complement format. If the number to be converted is a negative number, the second argument for the function, the number of characters in the result, is ignored. There are always 10 characters in the result for binary, octal, and hex. The functions that convert binary, octal, and hex to decimal will also work with 10-character binary, octal, and hex numbers that use 2's complement format to display negative numbers. The table shows the converted numbers converted back to negative decimal numbers. Google Sheet also has a generic function, base, that enables you to convert a positive decimal number to a specified number base. The base function has two arguments. The first is the decimal number to be converted, and the second argument is the number base. The table shows that negative decimal numbers cannot be converted using the base function, so I have removed them from the table, and now show decimal numbers to be converted up to 36. The table shows that a number base of 1 is not allowed. If you think about it, a number base of 1 is not possible because a number base of 1 only has one possible value for each digit in the number. All the number bases have to have a value of 0, so a number base of 1 would only have one valid number for each digit, which would be 0. So the only possible value in a number base of 1 would be 0. So clearly a number base of 1 is just not a valid number base, and Google Sheet provides a hash num error. So the lowest valid number base is 2, which is binary. The table shows a few example number bases up to 37. In hex, the digits in the numbers are 0 to 9 and A to F to give the 16 digits required. For the number base of 36, the digits are 0 to 9 plus the 26 letters of the alphabet from A to Z. Since Z is the last number of the alphabet, 36 is the highest valid number base in Google Sheet. The table shows that a number base of 37 is not valid and produces an error message. The decimal function converts any number base from 2 to 36 to decimal. The number to be converted will use the digits 0 to 9 plus the letters A to Z to represent the number. The decimal function has two arguments. The first is a string representing the number in the number base specified by the second argument. This table converts the numbers in the previous table back to decimal. For example, in number base 36, the number Z, when converted back to decimal, is 35, which is correct since it matches the number in column A. Finally, a quick look at the maximum and minimum allowed numbers in binary, octal and hex conversion functions. Binary numbers have 10 bits, so the maximum allowed decimal equivalent number is 511, and the minimum allowed number is minus 512. I've also shown that the hash num error is given for a decimal number 1 higher than the maximum and 1 less than the minimum. Octal numbers have 30 bits, so the maximum allowed number is significantly higher at 536,870,911. The minimum is negative 536,870,912. And again, the hash num error is produced for decimal numbers higher than the maximum or lower than the minimum. Hex numbers have 40 bits, so the maximum is even higher as shown. The maximum number for binary seems a bit tight with only 10 bits. However, you can use the base and decimal functions to convert much higher numbers to or from binary. The base conversion function uses 53 bits compared to 10 bits, so this should be more than sufficient for all but exceptional requirements. To convert the other way from binary to decimal, the decimal function converts 255-bit numbers. That is really a massive number, so I don't think anyone would need a bigger number than that. However, I would urge caution when using extremely high numbers. As you can see in the table, Google Sheet has translated all of these decimal numbers to the same binary number. Hopefully this video has provided you with all the information that you need to know to convert between number bases.